Do you just go back to the main slide for 1 second?
Yeah. Can I continue?
Yes.
Okay. So quickly on the agenda for today, we will first have a short introduction about the project and today's topic by the different member of the Robotics for EU consortium. Then we will ask you to fill in a Zoom poll, and then we get into the juicy part of the workshop. So we will have a presentation by Ladislav Dvorak from Robotwin, and then another one on Industry 5.0 technologies by Dr. Angel Dakal from CTAC. After that, we will have a short break to just stretch a little bit, and then interesting presentation from our Robotics for EU partner LNE on the RoboCompass. And after that, we will divide into breakout rooms and discuss different societal challenges of robotics for agile production. And later come back into the main session, have a final poll, and then closing around 3 o'clock. So I will now give the word to Lucas, who will introduce the Robotics for EU project.
Yes, thank you. Well, hello, everyone. I want to start off by thanking you all for joining from my side as well. I'm very excited to hear from the speakers today, and especially also your discussions later in the breakout room. So I'll try to keep this project overview relatively short by starting with the aim right here on the next slide. There's not many slides, I promise, so I won't have to say that too many times. But yeah, so the aim of our project is actually we try to boost the widespread adoption of robotics in the EU, and we do that by focusing on the non-technological barriers. Now, your first question immediately should be, what are these non-technological barriers? And I'll give you some examples. You can do something with socioeconomic barriers, could be data or legal. So everything not to do with actually the technical part of the robot. And we do so by promoting these responsible robotics principles. We do a lot of awareness raising. We participate in a lot of events, but we're also developing tools for robot developers to kind of spot and see where their gaps are related to these non-technological barriers. And if you can put the next slide, I will tell you something about the focus areas that we're in. So we have 4 focus areas. It's healthcare, inspection and maintenance, and agri-food and agile production. You see also here underneath those focus areas a little bit more about all the partners that we're collaborating with, either in the past or in the present. And on the next slide, I would like to extend this kind of collaboration also to you. So I'll briefly talk about what we've done in the past. It might be useful for the projects that you are also working on and what we're currently doing. So what we've done in the past, we've done a societal needs analysis. They've kind of mapped all the current social problems within the robotics field. We've done a citizen consultation with over 700 citizens, and all of these reports are on our website, by the way, so you can take a look at it. It's all publicly available. We do these sector workshops. That's also today, it's a sector workshop. And we're doing co-creation workshops. Here we actually fly over some, for example, agile production, robot developers, as well as the end users, and we put them in one room and discuss these non-technological barriers. And it always is quite interesting, let's say like this. You can see really in the room what's going on a larger scale. So I can definitely note this down if you're interested in this. We're still organizing the agile production workshops for this. We also have a virtual exhibition. With kind of this VR room where you can see a bunch of different robots and read about them. Yeah, so we do actually kind of do a lot of different things. Currently, we are working on our policy recommendations for the European Commission, for which we always need extra input. So if you're willing to help out on this part, please also let us know. Jovita will talk about this in a little bit as well. Of course, like I said before, these co-creation workshops, keep this in mind. But besides that, we're doing the Responsible Robotics Compass, which is kind of an online digital tool. We'll talk about this a little bit more also later. But basically, it allows robotics developers to quickly get an overview of where their gaps are, and we can help them improve. And this will all be hosted on the our little section on the AI on Demand platform that we're helping to create for the robotics community. So if you have any deliverables or any awesome things you would like to share on this platform, then also please let us know. We're collecting them from all different fields. You might have something to do with legal, so maybe something to do with data, or maybe something to do with robots. We really need it all, and we can put it there. So that's enough for me so far. I hope that we're going to have a lot of fun and a lot of interesting discussions today. I'm really looking forward to it. So I'll hand over the world back to Sylvia.
Yeah, thank you, Lucas. And yeah, as you said, and also I will share my and Lucas's contact at the end of the workshops, especially for the upcoming co-creation workshops. We are very open to hearing from you if you're interested in participating, bringing your robots or as end users. So yes, based on this framework of robotics for EU and boosting wider adoption of robotics in various sectors, today we will be focusing on the Agile production sector. And the title of today's workshop is Beyond Industry 4.0, because we want to also focus not only on what is happening right now and the current employment of robotics in the automation processes, but also what is going to happen in the future. So people are starting to talk and plan for Industry 5.0 and this more close-knit collaboration between humans and robots. But that, of course, has also a lot of societal implications and non-technological implications. And especially when we look at the workers' side, there is a lot of different narratives. Is this robot-human collaboration meaning that the workers will be de-skilling, upskilling, or reskilling? So the ultimate question for us today to you is, what are the greater repercussions of this change for society and for the labor market? And as also Lucas said, the policy dimension is very important for us. So I will now give the word to Jovita to briefly introduce also what are some of the policy solutions and aspects in this area.
Thank you, Sylvia. Hello, everyone. My name is Jovita, and as mentioned by my colleagues, I'm coordinating the process of providing policy recommendations for European Commission as well as national policymakers. And the aim of those recommendations is to identify what societal barriers could be alleviated by the policy measures, and also how the policy measures could contribute towards ensuring the deployment, design, engineering of responsible robotics. So in regards to this topic, the socioeconomic implications to society while adopting robotics in agile production settings is very much important, because that's one of the sectors that is actually discussed as very commonly, and that it is very, usually it's very, famous that, okay, there are a lot of job displacement, a lot of impact for workers. So we really want to look during this workshop of how to approach these issues and what policy solutions could be suggested to alleviate the impact and to ensure that the transition for workers is beneficial for them, and that the benefits in the process of adopting robotics is shared fairly, and ensuring that the workers are not left behind and they are included into this process as best as possibly. So that's a short introduction, and I hope that while we're discussing the implications, societal implications on the labor market, we can focus on these questions. So basically, what policies can be implemented to support the affected workers and facilitate their upskilling and reskilling, and also a question focusing on a risk of inequality is what policies can be implemented to promote equal distribution of the benefits arising from the integration of robotics in agile production. So that's shortly for me. I'll be very happy to participate in the further discussions.
Thank you, Jovita. And we will have occasion to discuss more in depth these questions later in the breakout rooms. So now we would actually ask you to take 5 minutes of your time to fill in a Zoom poll that we have created to understand what are your expectations for this workshop, and also what is your starting point of knowledge in a way. So yeah, the poll should be out now. So I will give you 5 minutes to fill it in, and then we will get back to the talks.
Is the poll working?
For me,
I can see it.
And for me, it disappeared.
Okay.
For me as well. After the second question, yeah. Second.
Now it's back.
Okay, so now it's back and you can answer.
Turns out you have to answer even faster than 5 minutes.
Can someone admit the? Yeah.
Okay, now I see answers coming in. Okay. We're still missing some. I'm giving you a couple more minutes.
There is one person in the waiting room.
Thank you for those of you also making some comments in the chat. It's very good to get some feedback on our poll as well. So if you have any comments, we are very happy to take that.
Yes. But yeah, I see the majority of participants answered to the poll, so I think we can close the poll. Thank you so much. And it's very interesting. Later, well, we'll see. If you're interested, we can share the results, but I see most of you are very excited about the prospect of working with robots. So I think we will are all on the same boat here and just want to make sure that we do it in the right way. Okay, so now we go into the first of our keynotes presentation. So we have here today Ladislav Dvorak, CEO of RobotWin, who will present on the topic of upskilling workers to robot teachers and his case with the RobotWin company. So let me stop sharing my screen. And Ladislav, are you able to share yours? Perfect.
Yes, so nice to meet you, everybody. I'm happy that I can also contribute to this workshop. And I can also be part of the discussion because I think that, that it all makes quite a lot of sense to work in this direction. So nice to meet you. I'm Ladislav. I'm the CEO of RobotWin, and we are a startup focusing on upskilling workers to robot teachers. We are bringing a smart solution for workers to easily teach and program robots. We were talking quite a lot about what's the impact of robots on people. But let's look on what's the this is outline of my presentation. I think that I don't have to go over this, or in the first part, I would like to show you what's the challenge some people are facing in their normal job. Because even we are having robots coming into many productions, there is definitely quite a lot of social issues with that. But there are quite a big issues still in the real productions where there are no robots. So moving towards robot is really a good direction. It has a few issues we should take into account, and that's the second part of my presentation. But first of all, I will show you. I will introduce the team to you because it's not about me; it's about the whole RobotWin team. We are actually a startup from Czech Republic, based in Prague, and we have Maggie as the CTO, who is the one who came with this solution, and he's leading the technical development of our teaching tool. And we have David, who is focusing on sales and communication with the customers. So if any of you would be interested to learn more about our product, then feel free to reach out to me or even to reach out to David later on. We have been seen already a few times. Latest event where you could hear about us was the European Robotics Forum in Odense in Denmark, where we were the third at the Entrepreneurship Award. But this is not that interesting. We are not here because of us, but because of the solution and because of the problem there is. So as I said, robotics has some issues, but real production, the manual production, which was here before and is still here in some productions, has quite some issues too. So this is a picture from a production Metalkov, which is in Czech Republic. It's a normal company, and everybody would expect that it looks already differently there, but no, it looks like this. And the worker works there 8-hour, sometimes even 12-hour shifts in such conditions, which has very bad influence on his health for sure. So you can imagine that this is not a job somebody would like to do. This is not an issue in Metalkov only, but it is also in big companies, in bigger companies who have, for example, even implemented Industry 4.0 already. They are talking about how they digitalize their productions, but there are still some operations which are fully manual because the robotics is not that yet easy and accessible for people. This is naturally, I think that I don't have to talk about this much, but this has a lot of disadvantages, not only in terms of health, but also in terms of like business development, because the entrepreneur or the company who is having such production has a very limited possibilities to extend the production, to have flexible production, and so on. So what's the problem? Why they do not actually put robots there, and why they don't replace this very unhealthy, demanding job? The problem is that for such, especially SMEs, the automation, we say, is broken. For such an SME, it would mean that they would actually lay off the worker who knows the job really well, who is a very good painter. They would have to lay him off, and they would have to hire or contract external robot programmers. These robot programmers usually don't have the experience with the technology, so they don't have the skills the painter have been collecting throughout his career. So this painter, this programmer enters this new task to program the robots for the painting tasks, and it doesn't work good because he doesn't have the know-how. It takes him quite a lot of time to program the robot, and he cannot program the robot for some difficult tasks because he is not aware of the specifics of the technology. There are some productions where it can take even up to 1 month to tune the final program for the robot because just the programmers don't have the know-how of the technology. This is supported also by the McKinsey research, which says that it's the second top challenge for customers is exactly the robot programming after the finance thing, that after the investment which is needed into the robotics. How we solve this issue? So we actually realize that we need the know-how of the painter, but we need to make him able to program the robots. So we created a teaching tool which we give to the painter, where when he performs the operation for the first time, we track the motion while he does it. We generate a robot program, and within a couple of minutes, the robot can repeat the movements of the worker, and the automation can work for the rest of the series. So in such way, the worker becomes the robot teacher without the need of writing some code, without accessing some difficult offline programming in the PC, without using teach pendant and saving some points in the space. He actually just performs the operation once, as he has always done it, and we just repeat the same skill by the robot. And this works perfectly flexible, because when they have a new product in the production, the painter comes there again, he creates the template again, and the robot can repeat that. The big advantage is that you don't need some different person from university or from somewhere who is coming to your production and replacing somebody else. You don't need a programmer. You are transforming this routine job, which we saw on the first slide and which nobody of us would like to do, into a collaborative and quite interesting work. We are reducing safety and health hazards for sure. And there is also an advantage that you can actually, one worker can multiply his know-how onto multiple robots in the production. And our technology can handle complex tasks, and it's for sure fast and accurate. This is a statement which is very relevant, I think, for this workshop, because that's Galatec is a company who is doing automatic paint shops. They are creating the automatic robotic productions for different companies. They are an integrator. And the sales director said that the paint shops need a painter transformed into a robot programmer, because they need actually the skill, the know-how of the painter, and they need him to program the robots. We have already gathered a lot of interest from the industry. We are talking currently. We have a close cooperation with Engel, with Austrian company, with Continental. We are cooperating with Dickert, Galatec, and these companies. These companies all struggle with this issue, and they are preparing for integrating our product into the production. One thing which I wanted to mention is that there are some legal aspects of the thing. There are some regulations on what needs to be done in the production. There is quite a lot of safety standards for the wet painting, which is the painting with the wet paint, and with the powder painting, there is a different norm, and this sets some standards that you need to wear a mask and so on. But it is still, even though we have these regulations which put some restrictions on running the manual production, it is still cheaper for quite many productions to keep it manual, to have people working for 8 or 12 hours in such productions, and not going into the automatic production because it's so difficult for them to automate. The manual production, if we look at the manual production, which we saw in the first picture, it is actually the regulation brings quite a lot of restrictions, and which is good, which is increasing the safety. But these, when we look at the manual production, they have to wear eye protection. They need to have a ventilation system, and as I said, they need to have respiratory protective equipment. But the issue with that is that it's still unhealthy and very demanding. And the reality is that in some production, these regulations are not followed. So the reality is not the thing what's described in the regulation. With the conventional automation, it's also quite difficult to integrate robots into the production, because a lot of these productions which we are addressing require an ethics certification. So if you know some of the collaborative robots which you can program by dragging, they are very user-friendly, I would say. This is unfortunately not applicable. So this is regulation which makes sense because it's an explosive environment, but it is also like restricting the use of robots, and you can only install robots which are industrial and which are much less user-friendly, and usually they require a university degree or quite a lot of previous experience to work with them. Our solution, as I said, is reducing safety and health hazards just by lowering the time the people are in the production, but at the same time, letting them keep up their skills, let them have and keep up with the skills of spray painting. At the same time, as I said, we are transforming the routine to the collaborative work, and at the same time, there are some ways how to automate the productions, which I was not mentioning, but these are very resource. They require quite a lot of resources, and they have a lot of, they are much more energy inefficient. And the robotic spray painting, when it is programmed by a skillful person saves time and resources. So this is everything from my side. I have a few points to discuss with you. So if we have some time, I will be happy to just if you bring some questions either to the chat or you can even say directly, I will be happy to answer some questions regarding the solution and also your thoughts about the approach.
Thank you so much, Ladislav. We are digitally, but this will be the moment for a round of applause, I think. And we do have some time if you have any questions, like 5 minutes for some comments on the presentation. So Ladislav already posed some questions here, so it would be interesting to know your thoughts. So please, I think since we are many people, it's best if you write them in the chat, and then we see if you can also unmute yourself and speak up, or I will read them out loud. Yes, Jens, I think if you're okay unmuting yourself, you can.
Yeah, I will start my video as well. Thank you for. I really like that approach. Really, it was very. But do you think this is? I come from Sweden, and I've been doing some. I'm really new again for industrial research, and my previous sort of occupation was financing production research. We do have some examples of modeling, spray painting and coating, electrostatic, where we program the robots from sort of models of the spray painting instead of doing that. But I see this as a sort of what do you call it? A first start for a company to start with robots, because then you don't have to do the modeling and stuff like that. So I really like that. So do you see this solution as the end game, so to say, or is it just the entry point for the company that are trying to introduce Industry 4.0 technology?
Yeah, very much. Thank you for bringing this topic. It's extremely strong for the entry phase, because a lot of smaller companies who are really having this production, this manual production, are afraid of that they will invest huge money into the robotic production, and then they will have new orders and they will not be able to handle them and to program the robots. So that's exactly for the entry phase. It's extremely strong. But even we have also customers who have already invested into robots. They are using them, but after even a longer time, they are still having, I mentioned that 40% utilization of the robots. That's because just some of the shapes of the products are so complex that it is hard to do it. And they need the solution now, even they have already quite a lot of previous experience with robots. And very much thank you for bringing the topic of automatic generation of robot programs. That's definitely a very interesting way to do that. We know companies who focus on that, but currently it works robustly for some basic shapes. And when you have some SME who is taking a lot of orders, you have a very diverse spectrum of products to be painted.
Yes, a lot of article numbers.
Exactly. Exactly. And sometimes they even don't have the CAD models, because they don't get them because of some security issues, or because the other company is not on such level of digitalization. So then this is not applicable for them. But our solution is actually creating a perfect input for creating some general know-how, because we have the inputs. We can also collect the the CAT data in some productions. We have the trajectories, and we can actually match objects with trajectories, which is a very good input for long-term training of some generation system.
Thank you very much.
Thank you.
Jens. Okay, let's take, I see one more question in the chat from Gabor, who asks, what is unique with your solution? So robotic painting exists from 1969. In Gabor's experience, robotic motion copy is not the solution, as the robot should learn what is the task and not the way of doing it. To reproduce programming time, you need to have sensors and a proper programming environment. At the end of the day, you will still need a system integrator to set up the cell. Yes, a technical question, but
yeah,
I don't know.
I'm trying to find the question there. What is unique about our solution? Yeah, maybe that's the question. The context of the other parts. What is unique about the solution is that we have a unique way of tracking the trajectory. There are solutions, older ones, which are using, sometimes they are using the technology which is used in gaming, like HTC Vive, which is actually tracking the motion of the worker's hand by having some senders or transmitters which are static around the painting cell, and the receiver needs to maintain a line of sight between the transmitter and the sender. But this is not applicable. This is not working well in the reality, because the painter or the manual worker who is preparing the template very often goes somewhere where the line of sight between the transmitter and receiver is lost, and then the trajectory is immediately discarded or lost. So this is unique, the technology of tracking we are using, and that's
Yes.
what I would say.
Mm-hmm. Thank you, Ladislav, and thank you,
Yeah.
Gabor, for the question. And also,
Yeah.
Ladislav, if I'm correct, you will also stay for the breakout rooms discussion. Yes.
For sure. Yeah.
So if you have more questions for him, you can also catch him in the breakout rooms. And I think that we can go to the second speaker then. So another applause for Ladislav. And now we will hear from Dr. Angel Dacal, who is area manager of the Factory of the Future at the Automotive Technology Center of Galicia. Yes.
Hello.
Sorry, the
Can you see my
cat is
screen
coming.
and hear me?
Floor is yours.
Perfect. So yeah, good morning, everyone. Good afternoon. I just wanted to highlight some new technologies in which we find social challenges, and I will just review some of them and share also some projects we are working. And yes, the objective is highlighting that things are not so easy as just using technology. Sometimes we have other issues on the board. Yes, well, this red dot is where we are located right now. We are a private research and organization, and part of our activities are R&D, and where we have some interesting facilities that, by the way, we use in different research projects. But just a brief presentation of myself. Okay, so Industry 5.0, understood as an evolution of the traditional 4.0 technologies, pays more attention to human beings. I think we paid too much attention in automating and in substitution of people with machine vision and with robotics, and that has worked well, but we have found some necessity of assisting and helping and actually collaborating. And I think the challenge right now is extracting the best from humans and machines. And this means not substitution of people, but collaboration of people and preserving jobs. And these, as we will see in this presentation, sometimes usually go through wearable technologies that they have own challenges. And the objective is building proper human-centric factories, not just letting technology in the factory to automate. As we will see, this is very well related with health and psychology and ergonomics, topics that are not usually in the cocktail, let's say. And well, my presentation will deal with two main parts. The first part will be physical assistant technologies, and the second part will be cognitive assistant technologies. if we talk about physical assistant technologies, the typical topic is human-robot collaboration, and talking about collaborative robotics. This means share a space between an operator and a robot versus the typical confined cell scenario that we find in most factories. And in theory, this was going to facilitate the human-robot interaction and new applications. But the truth is that we don't see too many really hybrid applications. Most of the times we just use a collaborative robot and we save the safety and the confinement cell that we used in the previous scenario, but not all of them actually are using a hybrid approach and extracted the best from persons and from robots. Checking the comfort of the operator is not usually in the priorities. This means that we just lay out an application and yeah, please start to use it. And this is sad, but it happens very often. The implication of the operator is not from the beginning. So the operator feels a threatened, feels a substitution risk, and we have not seen, I think, enough investment in dealing with this. The main focus is usually in the safety concerns. So we have projects like the project Cover we participated in the last years, very focusing, attending how to measure and how to measure the risks of a robotic application. And also we have lots of devices like these kind of sensors that stop the robot or play with the velocity of the robot depending on the presence of not of humans. And we have standards about that, but we feel a lack of investment, let's say, on the social concerns of these applications. I want to discuss about exoskeletons, which are a very special wearable device that aim to provide physical assistance. They provide protection, they restrict the posture, and they aim to reduce the muscular load in some zones, moving the force to other zones in which we can support more loads, like, for example, the legs. This had the origin in health and military, and in factories, they aim to statistically avoid injuries by removing a percentage of this effort. This is very nice because it's helping to include sensitive collectives and improving the productivity. We see a large variety of devices, dozens of devices right now. Depending on the area you want to help, you find this or another device. One interesting division is active and passive. Most of them right now are passive. They don't add any battery or sensor or processing unit, but at the right you see the Atlas and the Iron Hand. They are active and they provide assistance, but using sensors and batteries. The future, let's say, goes in this direction. And our approach in exoskeletons from CTAC is that we have tried to help to introduce them in industry because this is not obvious at all. An exoskeleton is manufactured for a specific task, but every workplace is different, every operator is different. So we have tried to demonstrate in the last years how much the exoskeleton is improving, and basically assessing if it provides more positive than negative things. For this, there are many protocols, but basically you start with a familiarization of the device, then you try to collect data from the operator without the device, then you collect the same data with the device, and you try to measure the results, this relative improvement. And at the right, you can see some real images from the stone industry and the logistic industry. There are three main approaches. The classical one is evaluating in the field. Basically, you go from a more simulated scenario to the field, to the manufacturing line, and you try that the operator wears different devices in order to measure different magnitudes, depending absolutely on the case. You may use temperature sensors, you may use heart rate sensors, you may use EEG or EMG. The most typical from our side, it has been EMG, by the way, and posture. For that, you can use wearable devices for measuring as well, because the more representative, if you don't disturb, let's say, the activity of the operator. And yeah, we have tried this in many fields. Just as an example, a project we are doing right now in the fish processing industry, very harsh environment, very complicated environment, people in the ship hanging and hanging frozen fish, and people in the factory manipulating very heavy pieces, like 100 kilograms, very narrow conditions. And well, it's a collective not so used to innovations and automation, and we are having very funny stories and very funny experiences with them. The safety concerns are critical because, for example, you wear an exoskeleton, but the question is, what happens if I go to the sea and I have to swim with this? Can I swim with this? So we are raising questions not had before. And another concern, if we are using a material which cannot be manipulated easily, like the fish, frozen fish, we are using mock-ups, and the mock-ups are these boxing devices that you're seeing in your screen. So, well, very complex environments to test and to introduce technology. A second alternative would be using benchmarking facilities, and we have been in projects like this one financed by EIT Manufacturing in the last years. And the idea is, instead of sensorizing the manufacturing line, working in a sensorized cabin in which you can develop your testings in a more convenient environment. The cabin itself is sensorized, and what we want to do here is avoid disturbing the operator, because this happens, and we disturb the operator, we disturb the production if we measure in the line. This is a solution from that point of view. The third approach would be simulation, but of course we are technologically a little bit far from that. It will happen in the next years, but then another questions arise. How can I measure the comfort of the operator in a simulation? How can I measure user acceptance? How can you take into account these things? So yeah, open research. I encourage you to work on that. In the future exoskeletons, we expect that they are active, more complex to control, probably lighter as well. They are still a little bit heavy. They will have more sensors. They will provide probably the effect through the material, like this one from the partners of Motor Skins. They will probably try to harvest energy. And well, the message from my side is they are slowly becoming actual robots that they are not right now. And this will have huge implications that we don't have still nowadays. Some brief comments about our experiences, social challenges of this. Well, obviously the operator feel invasiveness of the space. They feel weight. This is a very negative first impression. They have huge high expectations, like the Iron Man here on my right. So this provides a very negative first impression because they expect too much. And we find that not always all the sizes and anthropometric differences are covered. And again, in the gender, some devices still are not fully adapted for women, for example. The maintenance constraints are usually not fully taken into account because they provide heat. You have to clean the device. How are you going to solve that? And we don't have not enough studies probably in the long term. The shorter studies are fine, but not full 5-year, 10-year studies about that. Sometimes we have seen weakness and mocking between the operators. Haha, you are wearing this, you're weak, because then you need the exoskeleton, and this we have seen that. Others, on the other hand, seen this like, yeah, they are taking care of me. After years and years of automation, somebody is taking care of me, and they feel protected. So you can find everything. And what we have seen is that this is optional device. It's not a mandatory device. Some prefer only half of the sheet or maybe all the shift. So it's a very personal choice. We face a huge lack of legislation about that because it's not a robot and not a PPE. And well, from our side as evaluators, yeah, we have to be very aware of GDPR for all the data that we monitor. And in the future, if the devices are active, they will have to face as well about these GDPR concerns. If we go very quickly to cognitive assistance, here we try to focus in the technologies that provide some help to operators doing their task, providing some information to do it better or faster or with more productivity. The more classical approaches are AR, VR, XR, and other commercial products that provide some visual help and audio, and well, some projects that we have done in the past in this line. The consideration is that this invasion of my space through audio and visual information is clear. You are disturbing usually the production. So we have to look for the showing the information in a seamless way, which is not easy. Another important thing is showing the information in the right moment. If you have a long cycle time in manufacturing, maybe you are doing 7 to 8 things, how can you show the information in the right moment so you don't disturb? And without increasing the mental load, which is quite complicated. When we work with virtual reality environments, we have seen it's not obvious how to change from reality to VR and vice versa. We have seen, yeah, that this you cannot count on the operator to do it automatically as a robot. And then a very relevant thing, when you put this kind of technology in the factory is usually not autonomous to create content by themselves. They are always trusting in an external party, third party, and the truth is that factories are continuously changing the production processes. And this is a very important issue to keep these technologies in the factory so that they are challenging as long-term solutions. On the other hand, they promise a lot of improvement that's, of course, we have to evaluate in context with these social considerations. Some experiences we are working right now, a project of EIT manufacturing Selfex. What we want to do here is teaching operators through the experience of other operators. So the idea is using finger tracking devices. The idea is similar to what Ladislav presented before. We want to extract the trajectories of the movements of the operator. Then we want to show this to a junior operator, and then the junior operator can itself check again the same trajectory, and we want to measure the readiness of the operator through measuring this degree, let's say, of readiness, because usually you go to the manufacturing line through a we can say subjective perception of the training. Okay, so a lot of challenges here, but of course this is a new complementary method that we want to work in the future. Then there are all other cognitive assistant devices, commercial products that you can find in the market from commercial partners, where Health, for example, can measure the physiological load. GoX Labs, they have product about thermal stress and ergosante of posture. This is just a measure that you can find commercial products working in these technologies, many applications, but some missing opportunities in the factory. I encourage you as well to work on that. And one last example from my side, this project, No Stress Manufacturing, another ongoing project. And the idea here is to develop a stress monitoring and detector system for industry operators based on wearable information. So using part of the devices I showed you before, maybe we can detect and predict the degree of stress on operators. This is a new research line, and we are working with all this consortium trying to build something nice in this line. Some comments about all these things and technologies. Well, GDPR, of course, in the moment you are handling information from the operators, how to handle that, and you have to know the legislation very well. All the biases that we face when developing these algorithms, gender, age, and size, and culture, and many of the things that you only face when you have a large variety of subjects. The same, invasiveness versus the benefit that you provide is not clear. We all like to test technology, but operators in the factory are human beings with specific needs. We don't see many focus in emotions. I think it's a very nice research line, and I know partners from Technalia working on that. Yeah, we have to talk about that in some moment. The involvement of the operators in all these projects, they are the focus. They should not be as a product and just talking with them at the very end. And again, the maintenance and the long-term usage of the technology in the factory, because factories are very busy environments, let's say. And on the contrary, the benefits, of course, we want to improve the training processes. We want to save the know-how of the operators. We want to facilitate the creation and consumption of content, but obviously the mental and physical load of the operators is a huge challenge. And just to sum up, this 5.0 field is very interdisciplinary, and we have to count of very different teams and experiences and backgrounds. I think we will see a lot of new applications about that in the future and regarding wearable technologies, because they are getting cheap and they will be integrated in factories. But yeah, as the leitmotif of this seminar, we need more attention to ethics and the point of view of the operator and emotions and legislation, and well, a lot of things to do. Hopefully this project we are working with, I think is very necessary and a very good initiative to put some order in this. And that's it from my side. If you have any questions, I will be happy to answer.
Thank you so much, Engel. A round of applause to you too. And I know you will have to leave soon, so I'll just open the floor for questions or comments. If anybody wants to comment, please feel free to raise your hand or write in the chat. No? Okay. Jovita.
Thank you for a really interesting presentation. What I really want to hear more is that in your work, have you had those opportunities to look deeper into the well-being of the operators and how they approach these processes. You mentioned the fear of being substituted, but also can you share more what you discovered and which direction should be really emphasized in the further research? Thank you.
Well, my experience is that they usually arrive to the project too late, and they should be the focus in every automation, in every robotics project, in every project of probably more exotic, the ones I have presented. The truth is that by some reason, the factories, most of the times, not all the times, but we reach to the factory with the solution already packed, already finished, and now, so you have to explain everything to somebody that maybe has another point of view, very interesting point of view. Maybe they feel threatened by that. Maybe they don't feel comfortable with that, and it's too late. I think, the truth is, I think we don't usually think enough of the human being that is going to consume the innovation and to absorb it. So we try to avoid that, but of course, in projects that the ones we are usually working, you can put a lot of stress on that, but it's not usually the case all the times.
Thank you, Vita, and thank you again, Angel, for the presentation, and Ladislav too. Once again, virtual round of applause. It's two here. And I think that you gave us a lot of points for discussion later in the breakout room. Also, like this last point of inclusion of the users into the development of the robots is, of course, very, very important. And this idea of the human-centric technologies. So after this, we will, let me share my screen again, sorry. So now we will have actually a short break. And what will happen after the break is that we will hear about the Robotics for EU RoboCompass. So what Robotics for EU is working on doing is getting all of these social issues and actually developing a tool that can help robotics company to assess what are the societal issues or like non-technological issues that can come up of the implementation of their robotics solutions. But first, let's have, well, actually, no, sorry, 10-minute break. So we can be back at 2:10. You can stretch your legs a little bit. So see you in 10 minutes.
Hi, Sylvia. Can you hear me?
Yeah.
Probably you can stop the recording now.
Will it not stop automatically? When
No.
Okay, I can stop it.
So you can stop and see if you can convert it after, or I can also stop it.
But we still have the presentation from Anne.
Oh, yes, sorry.
Maybe we still record that.
Yes.
Yep. Perfect. 10 past. So we can come back. I see videos coming up again, so everybody's here. I hope you stretched your leg a little bit and that the weather is nice. You could take some air maybe. My allergies are pretty bad today actually, so I'm staying inside as much as I can. But let me see if Anne, are you here?
Yes.
Perfect.
Can you hear me?
I will, yes. Okay, so I will give now the floor to Anne from LNE, who will present the Responsible Robotics Compass.
You will pass the slides?
Yes, just tell me.
All right.
Next.
Okay, good. Well, thank you. I will try to be brief because I only have 5 minutes. So we can go to the next slide. The Responsible Robotics Compass is a tool to assess the social maturity of robots. We have defined that this tool is necessary for all the stakeholders around the robot, so both for the designer to have some visibility in the gaps in the development of the robots and to ensure that the robot is in line with their values, for the consumer to know that they can trust the robot to respect their values and that the designer is ethically compliant with them, and for the society as large, in order to promote the acceptability of robots, it is useful to have a tool that allows us to measure this acceptability. Next slide, please. Oh, sorry. Yes, so in order to design this tool, as Lucas has said before, we have conducted a lot of surveys and desk research and interviews with both the robotic community, the policymakers, and the general populations, the general public. So we have tried to gather what issues, what are the worries of different stakeholders and which are most important. And we have summarized this in our tool, which I will present just afterwards. Just come the next slide, please. So all of these issues, we need to categorize them, to organize it in order that to have a readable score at the end. Next. We have defined all of these issues, let them on the table and try to organize them into categories that are mutually exclusive and collectively exhaustive. So all of these categories cover all of the issues that we identified, and they do not overlap, or as little as possible. The 5 categories that we defined are environment, socioeconomical issues, legal issues, data, and human experience. For example, and each of those categories is then subdivided into subcategories and sometimes sub-subcategories, and the issues are listed afterwards. Go next slide, please. So for example, for the environment, we have identified 4 subcategories. We have the issues linked to production, to logistics, to the lifetime, to the operation of the robot, and the end of life. And for the lifetime, we have the operation and the maintenance. And for the operation, for example, there is 4 issues that were identified: the destruction of fauna flora, the pollution that is by design, that is a robot is, for example, spraying some chemicals, and the pollution accidental, if there is some spillage in case of an accident, and also the use of resources, so the fuel, electricity, etc. So for all of these categories, there is this detailed detailed issues that are that are categorized, and what we will sorry, you can go to the next slide, please. And what we will do, we will put all of these issues into a single assessment tool. Next slide. That will be a self-assessment checklist that robot manufacturers can take, which will measure separately the risks of that this robot has in this area and the mitigation steps that the manufacturer can apply to reduce these risks. So for environment, we'll have environmental risks and mitigation steps, and for each of these categories, we'll have these two assessments, which then, next slide, we will, oh, sorry, yes, there's some animation. Which then we will use to have a risk assessment, a mitigation assessment, and also we will be able to provide some guidance in order to improve the maturity in these areas. So then in our model, in the robotics, responsible robotics compass, we compute a score based on these risk and mitigation scores. And this is just a visual here. It's currently being implemented in the on a clean and beautiful platform, but it will look like this. We'll have a score for a category and scores for all of the subcategories with a risk score and mitigation score and some explanation of why these scores are what they are and how to improve on this. And for the next slide, the idea of this tool is it's for self-assessment. You just give honest answers and you receive honest recommendations. And we hope that these recommendations will be helpful, that we give as much power as possible to the robot manufacturer. For example, the relative importance of the different categories can be configured, will be able to be configured by the manufacturer. And you can take repeat assessment in order to see your progress during the development of the robot. You could take a test at the very beginning when you only have a prototype, and a test when you are going to manufacture it, and a test when it's already on the market, and to see, okay, our risk has increased, but we have put in place great mitigation steps, so we're good. And so that can give some insight into the development. And also this tool will be available on the AI on Demand platform. It is currently being implemented, should be online in about a month. And it will also give you the possibility to contact experts if you need some additional guidance, and also to contact us if you have some feedback. So right now it's in beta testing. So the next part in the breakout rooms, we will have some surveys. So this tool will have implemented it in the form of a survey. Right now, it does not give the result of the assessment. We'll need to process it by hand. But then we can contact you and tell you how you did, and maybe we can have some one-on-one discussion and and see if you have some feedback. So the idea right now is to put our tool out there and to see what you think about it. So, and if you're interested, it's always possible to do some one-on-one testing and some discussions. So just contact us. So thanks a lot. I did not hold my 5 minutes, but not too bad.
It's okay. Thank you, Anne. Yes, as she said, we will now go into the more interactive part where you can also help us with this RoboCompass, understanding if the categories and all of the questions and assessments that we are putting in place for this process are interesting for you and make sense. So we'll now divide into 5 breakout rooms. I have already created a breakout room, so you will be sent directly into them, and there you will have facilitators who will help you understand what you have to do. If somebody is not assigned to a breakout room, it's just because maybe if they just joined, I haven't assigned them yet. But I will see you back soon in half an hour in the main session, and I will now send you all into the room. Perfect. Who is being left behind? Okay, I have to go in my breakout room now.